Today we're taking on a topic that we think is extremely interesting to this audience, of course, and also to our customers at Kadiska, the introduction of how visibility to modern applications that are hosted on the cloud and SaaS applications are becoming much more difficult to access in terms of performance monitoring from individuals working at home, from different sites that are largely distributed. And as all these interconnected applications start to work together on the cloud, more and more obstacles for APM and NPM tools. We want to take you through the landscape of that, the challenges, and also the different ways you can approach them to regain visibility end-to-end on these applications for your users. So I'll pass it over to you, Boris.
Yeah, thank you, Scott, for the introduction, and I'll try to get started on what's the best ways and what are the challenges around modern applications when it comes to measuring user response times and experience in general. I'll start on really what is the overall challenge, and that's the main topic for Kadiska. So that's really our sort of mission statement is about fixing that problem and providing visibility into those modern applications. To get started, I'll go a little bit back and go back to the time where most enterprise applications were accessed through a private network from control locations, really on-prem locations. So that was a time where most enterprises actually had a fairly good visibility on the user experience. And then with the digital transformation coming in and the cloudification process getting started, we had a certain number of things that were extremely beneficial from a deployment standpoint, from a globalization standpoint, from a cost standpoint, and from a flexibility standpoint. But those things came with visibility gaps as far as visibility is concerned. So we had it, public cloud, moved workloads from data centers to public cloud, moved to SaaS for a certain extent. That's really for the sort of where applications are hosted. And then from an access level between users and application, we've started to use, a different kind of network, public networks and internet networks. And also with that came SD WAN that built private circuits around those public networks and new solutions that come from where users are located. Users are spread. Obviously, the pandemics has boosted, the work from home situation and make it a general case, which means that some new protections and new systems came in the past from users to applications. I'm thinking of secured web gateway solutions, CASBs and SASE solutions in general, protect users that are outside of the perimeter of their corporate networks, okay? And come as either a replacement or an alternative to VPNs, okay? With all of that came a certain number of visibility gaps, and that's really what this presentation is about. With that came a certain number of challenges for traditional visibility tools, and by visibility I mean mostly application performance monitoring in the old tooling and network performance monitoring. A lot of those things did not really make the jump or did not adapt to that new environment. So APM cannot really adapt to SaaS and PaaS platforms because you can't really implement it that way. And the scope of APM remains very on-premise focused. NPM faces another set of challenges. So the first one being similar to APM, which is that network performance monitoring solutions cannot really be implemented in SaaS and cloud platforms because you can't capture traffic there in a way which is efficient. So they miss the input to generate visibility metrics. The other thing is encryption. All of those flows are carried through public networks, and obviously you wouldn't like that to go in clear. So the encryption is generalized and far more difficult than it was to gain back visibility. And the last part is the way those new networks work. I mean, public networks are dynamic by definition. So the path that you follow can change at any time. It can change based on the user's location significantly. It means that also people can be redirected to different places depending on where they are and which operator they use to actually connect to those applications, creating a new set of complexities that make getting visibility into that far more complex than it was before, or almost impossible. So that's what this presentation really is about.
That's amazing. We'll take a look at really how impactful SaaS really is to the end user, and then we'll take a little bit of a look at the work from home remote users as well. But now 80% of business critical applications are built on software as a service. And these are increasingly becoming interconnected to each other. So you have all the familiar, Google and Microsoft Office suites that are hosted online. You also have your communication systems, your CRM, your MRP, manufacturing. And when you look at the bottom there, the point about composable applications is really a trend that we're seeing many SaaS applications and third-party applications being interconnected together with existing private and hybrid data center hosted applications and components, databases, backends, making extremely interesting from a perspective of trying to keep track of all where the performance leaks can happen, where the pinpoint where the bottlenecks are. And this has also affected the IT infrastructure and the IT tools themselves, where IT is also using a lot of SaaS applications to actually assure performance and also deliver the performance. And we'll take a look at those over the next couple of slides. Just before we do that, I wanted to introduce a quick poll to the audience. And in this case, I wanted you to reflect for just a second on exactly how many SaaS applications you actually use at work. And when I reflect on this, I think it's pretty much everything I use, except once in a while I open PowerPoint. That just seems to be the one that sticks on the desktop. But when you look at things like we use HubSpot, the G Suite, communications tools like Slack, Trello as a project management tool. I mean, Boris, I think you must have a half a dozen or more on your computer running, or not on your computer.
Well, my brother on the different devices that we have. I mean, most of the application estate at most enterprises now SaaS. So, and one of the interesting question is that does IT actually know how many SaaS applications are in use and are critical to the business?
Yeah, it's quite a large range, and actually you're right. Sometimes now we can't even tell what is software as a service versus something you would normally see as a desktop application. And we used to have our desktops covered with icons, and now really it's just tabs that are open. So I'm looking at the results on my end here, and it's saying that most people are running between 5 to 9. That would be about 70% of the respondents, and another 10%, 10 or more SaaS applications. So you can imagine, since we're all doing different functions in our work, that it could be quite dramatic in terms of how many are really out there for the IT operations team to manage. So tell us a bit more about the challenges there, Boris, and how we can manage this.
Well, I mean, SaaS is not the only one, but it's all applications that mix SaaS with PaaS applications and the possibilities offered by public cloud platforms, and probably mix that with legacy. But a lot of those new applications come with high importance issues being reported. So when you look at the figures, I mean, 42% of SaaS users report poor performance, and it's actually very difficult for most companies to keep visibility on that and maintain their set of visibility. And a lot of the issues are actually not detected by IT. And if they are pretty hard to diagnose. And the main reason for that is the multiple layers that we use. I mean, a lot of people always think, of those new applications like cloud and SaaS like a simplification of the delivery of applications. So you've got a user, you go through the internet, you connect an application. This is far more complex than that. There is a lot of infrastructure involved in actually accessing those applications. I guess the first one, if we start from the user, is really going to be the redirection. So depending on where you stand or where your SaaS provider thinks you stand, they're going to redirect you to different nodes to optimize the latency between your users and the SaaS platform as a whole, which comes with the first set of new complexities, which is that every experience based on the location is going to change. Then you've got the Wi-Fi and the local ISP, which is really the connectivity attached to each user. And then you've got the internet pass. Basically, when you go through the internet, that's a dynamic pass. You can go through multiple operators' network without knowing about it. And that can affect, the performance you get. And then you've got CASBs in the middle, the likes of Zscaler and Netscope that actually protect your users from a certain number of threats, but also increase the level of complexity of your user to SaaS pass because they go through that. And that is also subject to redirection based on geography with possible errors. And that creates another set of complexity. And then again, the SaaS is more complex than a traditional application in the sense that it's far more distributed. So when you look at the SaaS application, you probably look normally in between 20 and 30 host names that take you to different things, to your authentication services, to the core app, to the API services, to sometimes to third-party services that are used by the SaaS platform and CDN platforms, which means that not only you go to different host names, but you actually connect to very different platforms from a hosting standpoint. Finally, I mean, you use in a lot of cases you use a browser that has its own behavior, from caching resources to how it's displayed to rendering, and that's very complex. And when you think of composable applications where you mix, different clouds, SaaS and PaaS and IaaS and your legacy application, there's another thing that has influence on the overall performance, which is the connectivity between those different parts in the application. So if your SaaS platform is connecting through an API to a legacy application, or your PaaS platform is connecting through an API to your SaaS platform to extract data, well, obviously that runs through a network, and that network can have an influence on what is going to be the end user experience. Okay, so that's the whole thing, and that needs to be monitored. And as you see, I mean, it's far more complex than what we used to have in the traditional case. So when we look at the challenges of that new situation and draw a list of the challenges we need to address to win back performance visibility, of course, the lack of infrastructure control. The old way of instrumenting application isn't going to work in that new environment. I mean, you can't place agents, you can't capture traffic. There are a lot of things that you can do anymore. You don't really have control on how that infrastructure is going to change through time. So SaaS platforms, PaaS platform release things without telling you about it. So you've got to imagine that not only you don't have control, but it's dynamic. Second thing, I mean, for the ones that looked at, user experience from the network point of view in the past, there's a big change. There is strong encryption in place. We had the film that hide everything you get from a traffic analysis from a point of view. So anything you had like indication of end user response times and breaking them down between, server processing and network latency and all of that is gone. Even if you look at it from a TCP standpoint, how can you distinguish, the sort of exchanges related to infrastructure layer, like encryption, encrypted session setup, and the rest? It's not easy, and you lose all sorts of visibility there. Third complexity challenge, our users are far more distributed than they were. Right? There's not a single point through which they go to those applications. So that means it's much harder actually to instrument because it's more distributed. But it's not only distributed on the user side, it's also distributed on the app side, on the platform side. So you can have things that run in different clouds, you can have things that run in different CDNs, you can have things that run in different places depending on where you connect from. So that is by definition very complex. And when it comes to the applications, the format of the applications has also changed and require a new perspective of how you measure response time. You remember, the old web applications, and when we measure every user interaction translated into a new page, and measuring page loads was kind of a good way to measure user experience or user response times. When you look at new applications, it's not the way they work. I mean, if you think of a very familiar application, I mean, BrightTalk is an example, but Gmail is probably an even more common example. You load a bundle that has JavaScript, and your user interactions are going to trigger scripts that will trigger API calls made to different servers or host names, and you are going to remain on the same page. The old metrics that we had around page loads, etc., are totally obsolete to that world, and we need to take a new angle to have a view on user experience. And the last ones are around, geolocation based. So depending on where you are and through which systems or which gateway you go through, you're going to be redirected to different places. That has a very large impact on those modern application access. So that has an impact on the gateway itself, but it has an impact on the hosting of the workloads you'll need to access to make your application work. And finally, there's the same question happening, but really in the application platform, because there are networks in between the different hosting platforms involved in the application platform. So how you connect from a Salesforce, say, to your PaaS platform, if you've got a composable application, or how a cloud-based application access an API in your data center has a huge impact on the overall experience you'll deliver. And that's also a challenge to measure that.
Yeah, it's really look at this, and from our own experience, it can be very challenging to decouple all of these different elements together when you're trying to figure out where the problem source is. And we'll have to look at that one. If you're working from home, though, this SASE and CASB kind of interface often is introducing or doubling your latency, and that is necessary, right, to have that security to these applications. But at the same time, when we look at how people expect to have a productive day working at home, in the last year, 32% of the people who left their job and went to a new one cited their poor performance of SaaS applications and IT infrastructure as their main frustration for leaving. So we can't discount that this actually has to be optimized. It has to be taken under control. In terms of the challenges, there's two aspects to it. One of them on the connectivity side that we talked about, diagnosing issues between the remote workers and the actual applications and hosts they're trying to access, is what Boris is referring to. And we'll look at this later in a live demo where you can see how the CASB or SASE or DNS directs traffic to different regions than you would normally expect. And that's something we commonly experience. If I look at where I'm connecting on this call, it's actually routing me through Western Europe, which might make sense from the BrightTalk perspective, but I'm in Montreal, so this is quite a long route for me to go to when there's actually local American servers. These kind of things depend a lot on what I actually have in terms of connectivity in my work from home environment. And the user experience from an IT operations perspective is significantly more complex than anything we've seen before, because each user is connected to different infrastructure in terms of ISP. Applications are connecting to the third-party hosts and where those are located. And this is kind of a challenge that suddenly looks like it's insurmountable. But in reality, with the right level of tracing inside the network itself, you can really decouple that very quickly from the application performance. And Boris will take you through a tour of that with some live data in just a minute. So yeah, just one other quick audience poll. We wanted to see if the trend is continuing for people working from home, the remote worker, the hybrid environment is starting to become more popular. But that's actually even more difficult for IT because they don't actually know always exactly where you are, how you're connecting, and why there's a different impact just because of your location. So this is something that's critical for all of us to kind of understand in the performance optimization and management industry. Where people are, how often they'll be doing this, will they be back in those on-premise locations again and really trying to, control the traffic the way they used to, or are those days really gone forever? And I think we know the answer to that. So just looking at the poll results as they're coming in on my side, it's looking at the vast majority here, 3+ days per week. A small group that's still working at home only 1 or 2 days a week, but we're looking at about 70% or more out of the office at least 3 days a week. So it's quite an amazing spread.
Let's double click on, the myth of the traditional monitoring solutions when it comes to performance in those modern applications and why they will face some difficulties, and then we'll be able to go into the new ways we can look at performance. So when we look at network performance monitoring solutions, I mean, the main challenge is traffic analysis. And why traffic analysis isn't working? I mean, mainly because there's encryption in the game. And the encryption sides a lot of the application level behavior and everything that's related to user experience and user response times. So there's no way you can really have a view of response times and errors if you don't overcome the encryption problem. And is decryption a viable question? Really not. I mean, when you look at third-party provided services like SaaS and PaaS, there's no way you can find a way to decrypt that. And even if you implement, TLS 1.3, it's even hard to actually get a view of the decrypted traffic. And when it comes to implementing the traffic capture itself, so really capturing the packets between users and servers, well, the problem is all over the place. It's on the cloud side. So capturing traffic in the cloud is very complex. Normally, you use distributed platforms. You have a huge geographic spread to cover, worldwide audiences. Traffic in the cloud capture is both complex from a technical standpoint, it's also from an economic point of view a challenge. If we look at how you could, implement capture in the user side, it would be easy if people were located into a single place. If we take aside, the encryption. The problem is that it's not the case anymore. People work from home. People work from many branches. They've got many different ways to go through that. And finally, there's an even bigger challenge to add to that, which is how the network behaved these days. In the old world, to simplify things, you had a single pass or a limited possibilities in terms of how a certain traffic would go from a certain set of users to an application. With public networks, with SD WAN, with CASB, there are actually many ways you can reach that, and that's dynamic and that's changing all the time, not only because of networks, but also because of the redirections effect and the distribution of the different platforms. So that means that even if you've got some form of measurement, of the network component of the user experience, that doesn't tell you why, and that doesn't give you something you can actually action on to fix problems. And finally, the new protocols like HTTP2 and QUIC are rarely supported by NPM solutions and actually bring an additional set of visibility challenges really related to protocols and how they work. Okay, so if we forget about NPM and look at a different solution, a traditional way to look at performance of web applications was doing synthetic testing. I mean, most of you are probably familiar, but for those who are not, what does it mean? It means replaying scenarios, simulating a user that would connect to a place, click on a certain button, get to another place, and do things and make sure, one, it works, two, that the time to execute that would be within the norm or within the SLA that was set. Well, two problems with that. One is the fact that if you don't control the application, there's no way you can make sure that your scenarios remain valid all the time, and the maintenance of the scenarios is going to cost you an awful lot of time. And if you run tens or hundreds of SaaS applications, that is actually not practicable. And finally, it's not really adapted for single page applications. And the page load metrics that it provides are not meaningful for those new environments. And finally, when we look at RAM, that was also a traditional way to look at application performance for web application. It consisted in placing a JavaScript and collecting data from the browsers of your users. Well, that works provided you've got access to that platform. So in PaaS and SaaS environments, it's actually very complex to implement. It's also complex to implement in packaged application, where the software vendor doesn't offer you the possibility to actually insert that script and collect data in that way. So all of those traditional ways to look at user experience really do not align with the new architecture of modern application, and you've got to find a new way to capture the following drivers. So that's what helps us really present the overall experience and sort of break it down into different components and understand where problems may come from when they occur. So you look at it, you've got the user side on top, and then the CASB SASE layer, which is already sitting on the internet, and then some SD-WAN, and then the internet, and then you go across and you reach a very distributed application that has SaaS, public cloud, and all traditional on-premise workloads involved. So the first driver and the first thing you probably need to understand to monitor the user experience is what is my latency between my user and my users and my host. I mean, take a very simple example. I mean, if your users sit in India and your workloads are all hosted in North America, well, probably you can't expect them to have a great experience simply because of the distance and the latency involved. In the same way, if there is some form of inefficiency in the network pass between 2 points, you can get to the same result, although it's not a matter of distance. Finally, you've got both latency and processing involved in an intermediary step, which is called the secured gateways that come into place. So when you implement, something like a Zscaler, for example, that's a proxy you get redirected to. So you've got a first latency to that proxy, and then that proxy hopefully does some stuff. And every time you process and you apply security filters or protect your users, that takes some time to actually process that. And that's another source of problems that needs to be measured. And then you've got the hybrid connectivity. So what is the latency between that stage and the platform itself? So, your users to the SaaS platform directly, that might be through an SD-WAN overlay, that might take very different forms. And obviously that latency might change depending on which part of the platform you reach. So whether you reach the CDN or you reach the application core host name, you won't get the same latency as well. Browser and critical path renderings, what you load in the browser and how it's loaded in the browser also has a user experience impact. So it's never to be forgotten. That might be driven by both the browser settings, but that might be actually driven by the way the application has been designed and the JavaScript into it, etc. But that's a core driver of the modern application performance. data transfer. So what data you transfer, how much data you transfer, how compressed it is, when is it cached, etc., has an impact on the overall experience. And finally, the processing time of each workload or server involved in the platform. And there's a final one, which is what we call the intercloud latency. So what is going to be the latency between the different hosts inside the platform that need to talk together? So now that all front and back office services are not sitting in the same infrastructure, there is latency involved into that, and that can have a huge impact on the overall experience. So that's the sort of picture of what you need to have in your dashboards to understand the overall user experience when we talk about modern applications. And what you need to do with the data you collect about that. I mean, I guess the first thing you need to do is set some monitoring in place. So you need to understand, have a sort of high-level view of what is your experience in every user context. So obviously, performance is going to change depending on the location, the type of location, the geography of your users. So whether they sit in your headquarters, in a branch, in a certain country, or whether they are working from home, is going to have an impact on the sort of experience they are going to get. So that's probably the first important part you need, is relate user experience to a certain work context, a certain application usage context. Second, obviously, probably the thing you want to do is be able to identify issues in real time. So you probably don't want to wait for people to report. You probably don't want to wait for people to analyze. The response times to actually know about a degradation. You probably want that to be instant or be done in a matter of seconds or minutes at worst. Understand the scope. So understand exactly, okay, this is this part of my app, this is this type of users, they're using that type of connectivity, going through that type of gateway, so that you understand exactly, you isolate it and you understand what is responsible for the degradation and when it's happening, and what is the part of your infrastructure that needs to be looked into to find the root cause, which is obviously the next step. But if you haven't isolated the infrastructure layer, there's no chance you're going to get to the root cause. So you've got to have that intermediary step. Once you've got the root cause analyzed, you are probably in a position to either fix it or get one of your providers to fix the problem. And the difference between the old world and the new world is multiplication of the vendors you have to manage, and you have to provide information to. And if they say they have fixed the problem, you need to have an easy way to validate that it actually worked and fix the quality of experience issue that your users were having. Okay, so that's the whole cycle.
Yeah, I think that's one of the most actionable insights that can be provided in this sort of newer monitoring environment, is the ability to have a really intelligent, productive conversation with your vendors, because there's so many that are sitting between you and the user's experience, whether it's the host themselves or the CDN or your CASB provider. You can't just call them up and say we're having a problem when you don't really understand the scope of how many people are being affected, where they are, what they're trying to access in terms of applications, and that really unravels the problem very quickly. It's a time sink for IT to try to solve all of these problems for every user, unless they can see which ones are common to a lot of productivity impact across the organization. So I think that's the best way to show that, Boris, is as you have here, just bring up some live data and we take a look at what's affecting our users at Kadiska and also across the world today in terms of the key applications they use.
Sure, and I'll focus my demo, on showing, what are the challenges and providing you with some proof of, those difficulties and what you need to keep in mind. So that data is going to be based on fairly simple deployment. We have two ways to capture performance analytics. One is called Watcher, and captures the sort of real user experience analytics. So it gathers the response times and error data from all users that connect either to an application or for all internal users that connect to third-party applications like SaaS. And that gives us a feel for what is the experience based on the location and the way people access the applications based on, it gives us a feel for which host names and transactions are doing good or not so good in a certain application, and provide us with a view of what is the contribution of the different infrastructure layer. And when we have identified a certain infrastructure layer that's causing an issue, we get back to testing method to understand why a certain infrastructure, like a network connectivity, for example, isn't working as expected. And that's what we call tracer. Okay, all of that is accessed through a single platform, which can be instantly deployed and has self-driving maintenance in place. Okay, so when we look at a specific enterprise case, for example, say have a set of users connecting to a set of both internal and SaaS applications wherever they are hosted, using a mix of VPNs and secured web gateways to access that. The only thing we place is a sort of plugin on the browsers and the users, whether they are sitting remote or on site. And we have stations that do the net tracer, produce the net tracer data to analyze the infrastructure from the inside the enterprise and from hundreds of points on the internet to understand exactly what is going to be the sort of connectivity that we get to the different places from those two kinds of locations. Okay, so moving on to my examples, I'm just going to switch to Kadiska's interface.
So while you're loading that up for us, and I know it only takes a few seconds, so we have to talk fast. 3 questions have come in for the interface. So can you provide an example of the impact of Zscaler? We're thinking of moving to them and want to see if it'll work in our regions. Very specific question, but maybe one you can answer.
Yeah, that's yeah. I mean, we have some people coming to a certain number of applications in the platform that I'm using that do that through Zscaler or Netscope, which is going to be similar, but that's going to be the case. So the first thing we want to track when we look at that is really the performance metrics and how you measure, the performance of your SaaS and internal applications. So you've got a mix here of our own application and really SaaS applications, like Google Suite or HubSpot, which is a CRM, or Asana, which is task management. You've got a view of the number of users connecting to that, the time they spend on the application, the sort of latency from a network standpoint between the users and the platform. And then you've got a set of experience metrics for the traditional application, so how much time it takes to load a page, and for processing times. Okay, so the processing times are really going to be for single page applications. Most of the experience is driven by how fast we process API calls. Okay, and we can actually see that for remote users and for on-site users. Depending on what you want to see, you may want to see the number of users or the metric. And we can see that depending on what connectivity people use, or depending on their region, or depending on the platform they use or the browser they use. And if we have a question like your question about what gateway people use or what services people use and how it affects the user experience, well, we can see the same page with more data on the page loads and when we get errors, etc. But we can actually see a map here where we see the different users that we have connected on that platform based on the ISP, or for the remote users, or for the people that use corporate access like SD WAN sites. You see we've got sites in Toulouse or Belgium here, but we also have users coming through Zscaler. Okay, so we've got 3. We see how far those users sit from a latency standpoint to Zscaler, and then we see the impact, the overall experience, and broken down between the different layers. And the redirect time that you see here is going to be the sort of proxy processing time of Zscaler. So you see, for example, that's about half a second for each transaction, people using Zscaler.
Yeah, I was about to say that it looked like Netscope was maybe a worse choice than Zscaler.
I wouldn't be, as blunt as saying that it's always the case, but yeah, I mean, in the case of those users, we definitely see that people stand a lot further away from the Netscope connectivity nodes, about 4 times further from a latency standpoint. And you can also see that the redirection time is far more expensive from a user experience point of view. We're talking about 2.5 seconds per API call, which is pretty big. So it's about 5 times, the Zscaler one. Again, just talking about that very small sample and not drawing too fast a conclusion. I guess it also depends, on the capillarity, so where those providers, CASB providers, have got nodes all over the world, and where the audience and the users of each enterprise actually sit. So depending on the geographic spread of your company, those comparisons may flip and turn out to be the opposite. So that's really something where you have to look at what is the best for your own company, for your own applications, and your own spread of users worldwide.
It's always like that, right? Prioritize for one person in a certain country, probably not a great use of IT time if everyone else is having a great experience. And that's really what's important about the map, right? So you can see how many people are impacted where. So
Correct. You also have to pay attention to certain SaaS platforms, for example, that locate your instance in a single region, for example, North America, and then apply it for your whole set of users that might be spread, in APAC or Europe, and suffer from too much latency. So that's also a way for us to see where people sit, what gateway they go through, and what sort of latency they get to the different applications. Okay.
There's a question here, Boris, that just came in. It was, how can you determine if a third-party source or service is affecting the user experience for a SaaS application? I think you mentioned the examples of, Gmail having plugins, but how would you know if there's a host that's really impacting it?
Well, let's take the Gmail example. When I look at Gmail, I'm going to set, the same set of data. I'm going to get the same view of how people, access the application remote and from on-site locations. But I can also see what are the API calls that are fast or slow, frequent or not, and identify the ones that really trigger, long server processing times like this one, okay, which is here, which seems to be a JavaScript error. But you can also see the host names. And among the host names that matter, you can see the things that are plugged into our Gmail instance that are not provided by Gmail. So for example, Loom, which is used, to create videos that you send through email to explain stuff, has an impact on. It's not a huge impact, but it has impact. Some others, like this one, have. And that's also where you see the complexity of a SaaS platform. When you see the number of host names that really influence, the overall performance of your users, it's actually 4 pages. So you've got 40 host names that impact in different dimensions the experience of your users. So you look at HubSpot, which is our CRM, and is also connected into our Gmail interface. It has an impact, and you can see how much it has here. And you could go through 3, 4, 5 pages of host names like that have an impact.
Do we have too many things plugged into our Gmail, or is this typical for our customers as well?
Well, that's definitely the trend. People use multiple SaaS platforms. People mix, build their customer-focused applications in a way which is called composable applications, where they actually try to minimize the time in the maintenance of their applications by mixing SaaS platforms, and their old legacy, connecting through all of that data through APIs. That end up being that way in most of the cases. And the question when it comes to performance is, what is it about of that application that has a huge or a small performance impact? Okay. Mm-hmm. And usually, when people take a very simple look at their applications, they're going to look at, okay, mail.google.com, for example, is going to be the key host name they will test from an active standpoint. It's not the primary one that matters from a performance standpoint. There are many that have an impact. If you take another example, for example, if you take something like HubSpot, our CRM, you will see that, the app.hubspot.com, which is the thing you see in your browser, is going to sit here in false position as far as the impact on performance is. So those 3 lines here actually have more impact on the user experience.
So if I see that that's a network problem, and I'm sitting here in Montreal and you're in Paris, and I wanted to see, where is it that we're being directed to through our infrastructure? Can you show an example of how we would break down that path and really see
Sure.
if the network is a problem?
Yeah, if I use the user group view, for example, and I want to focus on you, Scott, I could easily, filter and say, okay, I want to look at what Scott did. Let's filter, get a view of all of your applications, and see, for example, I can see that you stand pretty far apart from the Asana platform. Okay, so that would be a way for me to look at that, which, I can filter and focus on Asana and say, okay, I want just Asana. And then I could see exactly when you had trouble, what was your connectivity, how it evolved. Here, you've not moved too much. You haven't traveled like you. So I see you've been in a single place. And then really I can get down looking at, when you had slow pages and slow stuff. And I could get to seeing what drove that. So when you seem to connect to your app.asana.com, every time there's a network setup, you stand very far apart. You're almost like 200 milliseconds away to set up a session to Asana. And then the server processing is pretty fast. And then what you receive takes a long while sometimes to be read and put ready to download more content from your browser. So that's the case in that line that we're looking at. And then you've got sometimes it's faster. And then you load a lot of stuff here, which take time. And if I want to understand that, I could almost get to exactly what I would have seen if I had been an analyst on your sitting on your laptop where you were doing that and looking at how it loaded and what loaded slow or fast.
So from a network perspective, 177 milliseconds sounds to me like I'm going over the ocean or something, or under the ocean to get there. We do a trace to that and see if it's actually the case right now?
It's very likely. I mean, that's the type of thing we see, with traces. For example, if I want to understand where performance is good, for Asana worldwide, you see a clear map. That's where we test it. So the more blue, the shorter the latency. The more purple, the longer the latency. So obviously, if you use Asana, you probably don't want to use it from APAC, and probably you don't want to use it from Japan because you would suffer massive loss. Okay. If I take another example like Slack, so here you would find something more stable, but you would see that people from the West Coast do not have great performance. And if you look only at the stations from the West Coast, you can locate where from you would have poor performance. So probably from San Jose, you would have bad performance. And from Seattle, it wouldn't be great. And if you want to look at why this is, well, you can do something pretty simple, which is look at that curve and look at when you have a problem. And you see here, latency was massive from San Jose until sort of 8:21 CET today. So we can look at that change and try to understand what happened. And here, if we focus on that period, well, probably we can see what is the journey from those two locations, so from San Jose and from Seattle. And we see that, okay, we go through very complex cloud networks, which are those dots. But you see that sometimes you are redirected to that location in the US, multimedia station, but sometimes you are redirected to Amazon in the US as well. And
they're totally different cities, right? I saw Ashburn there, and Chicago. And these are a way to kind of collapse that down to look at the most important service providers. So we just take a look at how that happened.
Sure. That and look through time. So you can tell, okay, at one point in time, the Seattle guys, they are redirected to Amazon to that IP address to connect to Slack. And the guys from San Jose are redirected to that point, which stands pretty far and which is in the UK. That's why they get such a different problem. And that's, the common trap when you start using cloud services and PaaS services and SaaS services. That's the common thing that happened. And as you see, at some point, people realize and fix it. But it takes them, when we look at the 7-day period, they've suffered from that for a long, long time.
So this information is useful to, who would I share this with first? Would I go to my ISP and say, how come I'm getting sent over there? Or is that really Slack that has some sort of CDN?
This is a simplified view, but if it's a redirection, it's up to the people that provide, the cloud service or the PaaS or the SaaS. If it's a different path that you see, you take a longer path here, maybe your ISP can help. But in a lot of cases, it starts with your SaaS or cloud providers.
Cool. One last question. And the question was, why wouldn't we just continue to use an agent that we probably already have something like that deployed on our user platforms? Why the browser extension? Is that easier to use or have a different advantage?
Yeah, I think, there are multiple reasons why a plugin is easier to deploy than an agent. One is what platforms are supported by an agent. So a plugin works across agents. So whether you use a Chromebook, a Mac, or a Linux or a Windows, doesn't matter. That's number one. The second thing is agent consume CPU to compute that data. We actually use data that is processed by the browser and we collect it, and the only overhead we generate is just a few kilobytes that we send every minute to collect the data. That's all, but that has almost no impact on the status of the endpoint. Agents have a big one, so that's one reason people stay away from them, because they probably have 3 or 4 of them actually already running on their endpoints and can't go beyond that. And the last point The last part is security. Because we work in a contained environment of the browser and we can't work outside of that container, and because our plugins are audited by Google and Edge and Firefox every time we release something, it's way safer than actually involving a new agent that will have to be reviewed by your CISO team.
This is great. I just want to point out before we close up the talk, there's a few more questions in the chat, and I will answer you directly after the session, just because they're great questions. We're just running out of time. And there's a couple of resources that might help you answer those questions. So if you look on the right sidebar, there's a little paperclip there where the attachments are. There's the presentation that we had shown today, as well as an overview of troubleshooting this kind of application and that kind of expertise through one of our blog articles. And of course, you can also always reach us at Kadiska. We're happy to show you the platform and let you try it out if it's interesting to you. It's very quick to set up and deploy. So something that won't take more than 30 minutes of your time to get an insight into your own applications from your user perspective. So thanks, Boris, for all your industry expertise. Always an insightful session to be with you. And we'll see our audience later. We have our Kadiska channel on Bright Talk, and you can see our other talks that we've given.
All right. Thank you, Scott. Thank you all.